Okay, there the recording goes. I'll have to repeat questions and such, but that means that you're not being recorded, but I am, just so you know, and I'll be posting this video online later. If you were to go to this URL that I'm displaying, workshop.frclabviewtutorials.com, there you can download the slides I'm running, as well as previous year slides and example code. I've also got some notes there on how to use Git version control with LabVIEW. It sounded like John, or Mr. Jones, was getting everyone set up with getting the installs going. Is that correct? Okay. I didn't take screenshots of making the install process when I went through that myself this morning. So I think I'm just going to skip that. I think the documentation is pretty good. Basically, you're going to download the NIFRC, unzip it, run the install everything if you're planning to use LabVIEW. If you're in this session, I hope that you are. And then you're going to download the FRC update suite, unzip it. You'll probably need the password, and then install everything again, and that will upgrade your LabVIEW to look exactly like the LabVIEW I'm currently going to be using here, because that's what I did this morning. Other than that, just follow the prompts. It should go pretty smoothly. And with that, let's dive in. I should also note I am a keyboard shortcut preference, and so to make sure you guys aren't missing anything, I have key press running down here in the corner, so it should show you what I'm hitting to move to different things. Basic overview of LabVIEW. You have so I heard a show of hands that most of the people in this room are new to LabVIEW. How many of those are also new to programming? Okay, so if you're familiar with programming, the VI in LabVIEW is very similar to a function, where the front panel is your inputs and outputs, and the block diagram, which I'll show an example of in a minute, is the actual body of the code. For those of us that are completely new to programming, you can also think of the front panel as your display, and then the block diagram, with controls on the display that you can mess with while it's running, as well as indicators that are outputs. And then on the block diagram, for those that are familiar with programming, this is basically the body of your code. For those of us who aren't, this is a region where I can specify what I want to do with those inputs and outputs to the segment of code that I'm trying to write. And everything that I've dropped on the front panel is available here. I have the controls again, and I also have my indicators. You notice that I've got my controls on my left and my indicators on my right, and that's because LabVIEW in general flows left to right. Collectively, these things are called the terminals. And I do have a quick demo for you. Oh, that didn't work. That's a bummer. I must have closed out of that. Okay. Wrong folder. Files. There we go. Alright, so I can run a quick demo for you if I want to. No, give me a new VI here, please. If I want to add more inputs, I'm right-clicking to bring up the controls palette. By default, it's also always visible. I don't like that, and I close it, so I just right-click and grab stuff. However, you can go to View and turn on the controls palette to have it back again. So if I right click and I grab, let's say I want a number input, maybe something like the angle that I want my arm to be at. I would grab a numeric control and then name it angle, and maybe I want an output from my VI that tells me if I'm at the angle or not. That would probably be a Boolean, a true-false value. One thing that's interesting about LabVIEW is just about anything can become a control or an indicator. It may change appearance in doing so, but by default the LEDs are your output Boolean indicators. So I might put true question mark to say that it's truly there. On the block diagram, I can go here and I can do a comparison. Again, right clicking to get the functions palette, and I can view to have it always open, but I find that annoying. So I right click and I say, okay, so if it's equal to that angle, then I want it to do that. Since this is just a quick demo, I'm going to hard code in what angle is currently at. If you stick around for the advanced session, I'm going to be going into a lot of different sensors and how to read them, and that'll help you understand how to do that. But that's going to try to drop it onto the RoboRio. Cancel that, please. There we go. I can run. Still trying to run on the RoboRio. Don't save. Add a new VI here. I'll just do equal to 0, make this go a little bit faster. So I've got my input, I do some sort of comparison, I've got my output. Real quick, simple. I run, and it's true. I run again, that's false. So what happens with LabVIEW is it's data flow driven. Most text-based languages, you start writing lines of code and you go top to bottom. And the only jumping around you have is when you go to a function. With LabVIEW, where the data is going defines the order that things will run in. A node or a object on the block diagram will execute only when all of its data is available for all of its required input terminals, which is all of them. And it only pipes out output once the node has finished execution. So if in this example, I can't tell you which one will be read first, the number 1 control or the number 2 control, or the 50, but I can tell you that the plus will always occur before the minus. It will actually take these two numbers out together and then do that. This is different from hardware languages where everything's going on in simultaneously, but very similar to text-based languages where yeah, I take these two and I take in the result, and then I'm doing that, so it will happen in order. And then just a quick demo of what it takes to read a joystick and set drive motors. I'm going to close out of this, don't save. So I'm going to redo that even. I'm going to create a project and show you how to do that, since most are new. Yeah, let's go all the way back to the launch screen. So this is the launch screen. This is what it'll look like when you first open it up, minus these open recents. Since I've already started messing with it, I've got a few recents available. But what you want to do is create an FRC RoboRio project. Name it something informative. I'm going to specifically call mine Kickoff Workshop, because this is the copy of code that I'm using this for. It's only going to be used for this today. I can close that up. And give it a team number. I'm an alumni of 3288, so I'm going to use that. Actually use your team number that is used for pairing up with your RoboRio and your radio and all sorts of the control devices. And yes, I want to overwrite that project that I created earlier. So this gives me the Project Explorer window. I've got the target, which is the representative of the RoboRio, and the code that will run on there. I've also got the option to put code underneath my computer, and this will be code that runs on this machine when I run it. You can't have dependencies on the RoboRio. You can't have things on the RoboRio that depend on things on my computer, but you can have them the other way around. This allows me to put test code on my computer. But for my example, I'm going to open up the main VI, robot main. this is the high-level code that in the architecture we're given is what you should be running for the primary of your code. And it gives you a basic setup that says, okay, when I begin, I'm going to run this. When it's in tele-up mode, I'm going to run this one. When it's in autonomous mode, start this guy, which is this one. And the whole time I'm also running this time tasks. And I'll explain more about each of these as I go. For the specific demo I wanted to do, when I'm running in tele-up mode, I'm going to go in here. There's some default code. Go to the block diagram. Okay, so we've got drive motors, set them to drive. I've got some joysticks that I'm reading, and it's actually setting, this is an index array, so it's grabbing the axes values on that joystick, and it's grabbing the first two. So if I had a attack 3 or similar flight stick controller, this would take the X and Y and pipe them into the arcade drive, along with the motors that I wanted to run, and that has your robot driving right then. All I did was open up a default project. But let's say I want to do a little bit more than that, and I want to actually control an arm or something. I've got tele-op open, that's useful. I'm going to go back to the Project Explorer, hitting Control-Shift-E, and you can do that by finding it on your taskbar. You can get a number of ways, but Control-Shift-E has been a very convenient shortcut for me. And in Begin, this is where you initialize everything for your robot. Go to the block diagram. I can see that by default I've got left and right motors opened up, and I've got a joystick opened up. I'm going to open up an additional joystick by using a control drag to create a new one. I need to give it a different name, so I'm going to call it joystick 1, and I want to read the one that's in USB slot 1, just because it's the next slot. On the driver station, yep, I even had it in my recents. Yes. In my driver station under the USB palette, USB devices will be, evaluate. USB devices will be recognized here, such as joysticks and cameras. Not cameras, actually. And the order that they appear in are 0, 1, 2, 3. I don't have any joysticks plugged in, so that list is currently empty. But USB 1 would be the second joystick in my list. I also want to control a new motor, so I'm going to go to the Functions palette, go to the WPI Robotics library. Under Actuators, there's a Motor Control palette. I'm going to go ahead and pin this open because I'm going to use it for a few minutes. And I want to open, just like everything else, we've got open store ref num. I know what that's called from previous years. If you want to know what things are being called, you can open the context help. I use Control-H to open it. It's also available under the help menu. And what it does is when I click on a VI, it gives me the description of the VI, shows me what's passed in, what's passed out, and the description that the writer put on it. So this is the robot drive dev ref num registry set. Real long name basically says store this in a dictionary. I'm going to do the same thing with my motor. I'm going to open a motor. I'm going to say this is a spark motor. It matters in that if you're using CAN motors, they are different, and you have to install the Crossroad Electronics CAN library in order to make that work. But for a spark motor that's running off a PWM channel on the RoboRio, so I can create a constant and say which PWM port it's on. I'm already configured for PWM 0 and 1 to be the left and right motors, so I'm going to put this on PWM 2. To clarify what I'm talking about when I say the PWM. Okay, so what I did is I highlighted these guys, I did a control drag to create a second one, changed to joystick 1 and USB 1. The reason I did that is to use the second joystick plugged into the driver station. And I'm going to redo this part. So I went to the WPI Robotics library, Actuators, Motor Control, Open Motor Output. I'm actually going to use this palette for a little while, so I'm going to pin it open. I want the open, and I'm going to say it's a spark. If I'm using a CAN device, that really matters, as opposed to a PWM device. They are different. If using CAN devices, you have to download the extra stuff from Crossroad Electronics. I'm going to say it's a Spark device, and that will enable me to plug, that means I'm going to tell it I'm going to plug it into a PWM port. I'm going to stop my screen sharing for a moment. So the PWM port, looking at the RoboRio, this side is PWM ports, PWM 0 is at the top, and then 1, 2, 3, 4. And let's share the screen again. Screen 1. So I've got PWM 0 and 1 by default set up to be the drive motors already. I didn't have to initialize those. So I'm going to set this new one to be PWM 2. And what I did there to create that input to this open is I right-clicked on the terminal and went create constant. And then I have the options for what PWMs I want to use, PWM ports. Once the motor's opened, I also need to do a ref num set. This is a standard setup that I actually don't like, but I'm not going to go into how to go around this in this series. You should go to frclivetutorials.com and check out the tutorials there on how to do this without doing all these names. But for now, for this demo, this will work fine. I'm going to call this ARM. If you do continue to do these name styles, know that they are case sensitive, so you have to get it exactly the same when you store it and when you get it out. So this is begin. I've opened a new joystick and a new motor, and I've set them with joystick 1 and ARM as my names. I'm going to close out of begin, Control S to save, go back to teleop. What?
We're having something weird in it. We're on behind Spotify. And it just connected to us. Keep going.
You're good? Cool. So did you miss any of that?
No.
Okay. So I went over to teleop and I dropped in the ref num get, and I used my ARM name to say what name of the device reference I want. And I'm going to use a set output to allow me to control the speed. It takes in a device reference and the output level I want. That's all you have to wire in. Notice on this reference they're in bold. They're the ones that are required. That allows you to basically set up what you need. That's all I need the motor control for. So I'm actually going to take this up and up, go back down into the joystick, and I want to do a get. And at this point, actually, wait, I already have this code. I'm going to control drag this down here and just change this name to joystick 1. So pretty simple. I'm able to revert what I just did and use existing code to get some variance. Now the get values gives me the axes, as explained earlier. That's an array. That's a list of devices with addresses, basically. And the way we access items in those addresses is by what we call indexes. So I'm going to go to the array palette, index array, and if I grab the axes array, and I can say what index I want, I'm going to say index 1, which is the y-axis on a attack 3 or other flight style controller, and I pipe that to the output. Now when this is in teleop mode, as I move the joystick forward and back, it will set the motor speed to that. I think the only thing I want to add about the index array is I can grow this, and what it will automatically apply that last value plus 1 to the next one. So this is defaulting to 0 and 1. I skipped a 1, and now this is going to give me index 2, where I can specify what index I want. Everybody good so far?
We're good.
Okay. Save that and go back to the PowerPoint. Case structures are a LabVIEW element. They have 2 or more subdiagrams or cases. If you're familiar with text-based programming, they're similar to the if then else or if else. What they do is they execute and display one case at a time. So the input terminals, you can tunnel things through this. An input tunnel is on the left-hand side, and you can create multiple of them if you want. Input tunnels are available to all the cases inside the code. If you have an output tunnel, you must define each of those cases out. And I have an asterisk on that because there is a way around doing that, where you can set the default value, or rather tell it to use the default value if it's unwired. And that's available through right-clicking on it. For repeating steps, you say there's both the while loop and a for loop. I'll explain more about the for loop in a little bit. For the while loop, the code that is inside the region is what's going to be repeated, and this terminal down here is the stop terminal. When this code executes and true goes to the stop terminal, that's when it quits running and goes on. In text-based languages, this is more often a do-while, so that is a little bit different. You need to be able to remember that it's a condition after. The while loop will always execute at least once. And you can, okay, that's a bogus call. My phone was going off. I was worried it was you guys again. In the while loop, you have a iteration terminal. It's a 0 index value. This is how many times the loop has run. So if you care in the code inside here how many times the loop has run, maybe you're trying to do a count. The count's available there, and you just pipe the count into your math. Also notice this is a different icon. You can change whether you are on stop if true or continue if true, and with the green arrow it's a continue if true. And that's everything I just explained. You can tell I haven't reviewed these slides in a while. So the tunnels, very similar to the case structure, they transfer data in and out of the structure. Unlike the case structure, there's only one, so you just have to define it, provide the values once. The data will pass out of the loop after the loop terminates. This is the same as with any VI. Data only goes out after it's finished, so if you have something downstream that needs that thing, it will wait until the first one is finished. And when a tunnel passes data into the loop executes only after data has arrived. In this case, I have a constant, so that's not going to matter. But again, if the while loop is behind something like a read joystick, the read will always occur first. Okay, quick demo on the while loop. For this, I'm going to create a new VI that's going to run on my computer so that I don't have to deploy it to the RoboRio to run. And I'm going to make a guessing game. So this is my guess. And inside the block diagram, using Control A to switch, I'm going to use a while loop to read that. And I need an answer. Just real quick, there is a random available. It gives me a random float or decimal point number between 0 and 1. I'm going to establish that before. I'm going to multiply by 10 to change it to 0 to 10. And then to make sure it's an integer so I can type it, I'm going to use the round toward negative infinity. This is very similar to the floor function that's available in most math libraries. And then I'm going to simply say that if they are equal, which is in the comparison palette, I'm not sure why I was in there. If the two numbers are equal, that is my stop condition. So when I get it right, that's when the program's going to stop. And I don't have to save it to run it. I don't know why I hit that button. Go to the block diagram, I can run it. 0 is apparently not right. 1, 2, 3, 4, 5. Okay, so the number was 7 that time. It is random, so it probably won't be 7 again. As far as debugging goes, while code is running, you can tell that because the run arrow is black and have the abort option available. I can click on a wire and get what's called a probe, and that will show me what the value is. So I can actually now go back to the front panel and enter 5 in directly, and that is the correct answer. So that's a real quick while loop. It keeps running. In this case, because it is the entire VI, it keeps the VI running until it terminates when the guess is equal to the answer. The other way to do repetition in LabVIEW is with the for loop. For loops are based around the count idea. And so it's okay, I'm going to pass in a number, and I'm going to keep doing that until my iteration counter equals that number, and I'm going to end. And they do that using the count terminal. So just a real quick, make sure everybody's on the same page. I'm going to describe some scenarios. I want you guys to think through whether you should use a while loop or a for loop. Scenario 1, I'm trying to acquire sensitive data in a loop that runs once per second for 15 seconds, or the autonomous or now sandstorm period. If you use a while loop, what is the condition that you would use to stop the loop?
Answer is 15 seconds.
Okay, so if the time is greater than 15, then stop. Yep. If I use a for loop, how many iterations does the loop need to run?
Answer is 15.
Okay, 15. Now, is it easier to implement the for loop or the while loop? Okay, I heard while loop. And that is the correct answer. And part of my reason, in this case, either one is fairly simple. But the while loop gives you the ability to say, okay, I need this to actually run every half second, but still run for the 15 seconds. Or any of a number of quick changes, and you can, it's still going to run for 15 seconds. Or you can change that 15, and you don't have to worry about the delay or period that it's running at. Where's my timer? It's a little after 1. I'm actually going to skip scenario 2. Which is read a gyro until it's less than 15. Again, the while loop, because the for loop, you don't know how many times you need to read going in. In the scenario 3, if you're trying to read both joysticks until both are negative, do you use the while loop or the for loop? Again, the while loop works better because you don't know how long that will be. And I'm just going to go ahead and skip scenario 4. So the FRC architecture, you start out with begin. That's where you create references for all joysticks, motors, and sensors. This runs at the robot power up, and not the game that we did last year, but when the robot is turned on. I opened this up earlier in the demo, and that's where I created the joystick and the motor that I wanted to use. You also have teleop, which is primarily used to read joysticks and set drive motors and actuators. This slide may be out of date now. I said this only runs in teleop and enabled. I was digging through the rules to try to understand how we're going to do sandstorm mode, and I could not find it. It's unclear to me whether we are in control of whether we're going to run the autonomous VI or the teleop VI, or if it will always run the autonomous VI, but we're allowed to do more in the autonomous. It's unclear to me at this point. I was digging through the rules, was not able to find that just yet. I'll probably be posting on my website, the FRC LabVIEW tutorials, details on how to do it once I get that figured out. And then autonomous, this in the past is run when autonomous is enabled and did not take additional inputs beyond one read of the joystick. With sandstorm mode, that might be changing. Time tasks is still available in the architecture. It starts once enabled, and continues during both auto and teleop. It's got some loops inside it. If you are trying to put code that controls a manipulator in one place, this is the place to put it. And then you can pass messages to that from teleop and autonomous, not at the same time, to tell it what to do, and then you only have the code on how to control the manipulator in one place. As far as how to deploy the code, I'm actually going to demo this. You can run from main, robot main, in this case, Control-Shift-E, go back to the project. Oops, I did not want that. And I can go to robot main, and I can hit the run button. I do not currently have a RoboVIEW plugged in. Give me a moment and I might. So this is actually going to fail because it's not able to find the RoboVIEW. So I'm going to go ahead and cancel rather than just waiting for it to decide it can't find it. Back to main. Okay. Thing to note about running from main, it sets the VIs running and enables you to interact with them, much like I did with my demo on while loops. I can probe, I can look at inputs and outputs, but it does not stay on the robot. Once the robot is rebooted, that code is gone. In order to get it to stay on the robot, you have to actually deploy. And to deploy, you go to, come on. You go to the Project Explorer, go to your build specifications, right-click on this, and deploy it. Before deploying, you should build. And one thing that has changed in recent years is if you want it to become the default program, you also need to run as startup. That tells it to be the program that runs when the robot turns back on. Okay, so run from main for testing, deploying puts it on, run as startup gets it going. I should clarify, when you deploy, that will mark it as startup. So if you reboot the robot, it will start it. But if you run as startup, that deploys and starts it running. So both of the latter two are used for offline, like when you're actually ready to go to a match. Running from main is used for debugging. One thing that you'll probably encounter a lot is broken VIs. That's when the run arrow looks like a broken arrow. And if I jump out of my PowerPoint, do something like this. This is invalid. I have both a broken wire and this is required, so I have a broken run arrow. Clicking on that broken run arrow pops up the error list. It says this is the VI that has a problem. This is the problem. This wire has loose ends. I can go here, okay, I'm going to delete the wire. I still have problems. The conditional terminal is not wired. Conditional terminal is required, so I'm going to wire that up, and now my run arrow is good to go again. Basically, when you're dealing with those, just go through the list that it gives you. There are rules like you can only have one input to a wire, which makes a lot of sense. You can only have one thing feeding data in. You can have multiple outputs, but the error list should pretty well clarify what is wrong. Also, possible scenarios are when you have no inputs because you wire two, excuse me, this is two inputs, no output, as when you've wired two controls together. The solution here would be change one to an indicator. Also, if you're trying to swap types, if you noticed, these wires have colors. Orange is for a double or a decimal point number. Green is for a Boolean. And you cannot wire two types together. There are some conversion VIs, but without the conversion VI there, that would be a broken wire. You can also have required terminals unwired, much like the loop condition, or on the open motor, the PWM input is a required terminal. If the sub VI is broken, that means you need to go into that VI and see why it's broken. So, sub VIs are VIs within your current VI. The open motor VI is a sub VI to my begin VI. As far as data flow, these are a little bit harder because that means that the robot does run, but it doesn't run correctly. Some things you can do to fix that. I've already shown you the probes. If I jump back over to my demo, this light bulb here is called highlight execution. If I turn that on, as I'm running, you can see the number go across. So I can see that the answer is going to be 1, and it's getting false out because my guess is currently 5. Again, I can just change my number to 1, and eventually it reads the 1, reads true, and the program terminates. Notice that that ran a lot slower. Normally I would... Sorry, say something?
No, we're good.
Okay. Normally that runs a lot slower, so you only want to run that on your desktop, not on the robot. Number one tip that I've heard repeated on chiefdelphi.com over and over again when somebody says that their robot's running slow is make sure you have this turned off everywhere. So that is a way to debug. I've shown you the probes. You can delete them in here. You can also close the window and it'll ask if you want to delete all of them. Last thing to show you is what's called single stepping. If I click on this point, if I right click on this point, I can create a breakpoint. Now it's now highlighted in red. If I start running, it's stopped at that breakpoint, and I can step over that point. I can step over the round, and I can probe these values and look, but this is pausing the execution as I go. Again, very useful for debugging, very similar to the step debugging available in most text languages. Generally don't want to do this on the robot because it causes wonky timing things, but you can do it on your desktop when writing a VI that's supposed to do some conversion or something like that. I can hit continue. One of the interesting things though is this is continuing, but that breakpoint is still there. So if I hit stop and rerun, it hits that breakpoint again. What I have to do is I have to right click on it, go to the breakpoint, and clear the breakpoint. That then allows me to run uninterrupted. By far and large, I view probes as the best of these. So when you're trying to figure out what's wrong, are they other things to think about is there are unwired or hidden sub-VIs. There are VIs available that have some defaults that you don't have to wire, but if you forget to wire them up, they may not behave the way you want. That applies to both of these top two items. Does the VI pass undefined data? Again, referencing default type stuff. If I'm calling a sub VI and I haven't given it an actual data, then it may not do what I want it to do. Numeric representations being correct, that mostly has to do with how large your number is. A double can handle 32 decimal points versus a unsigned 8. Does not have decimals, can only go from 0 to 255. For the most part in FRC, you won't be dealing with this unless you're manually setting them yourself. If you just use doubles everywhere, you should be fine. And then are the nodes executing in the correct order? And that can be a problem if you don't have two things that you meant to depend on each other to actually depend on each other. I'm not really thinking of a good example of when that is easy to get into. So terminals in LabVIEW have data types, terminal colors, text, even the arrow direction and border thickness all provide visual information. The orange represents a floating point number. I mentioned that a few times. Terminals with thick borders with arrows on the right are control indicators, so that's these guys, versus terminals with thin borders and arrows on the left are indicator terminals, making it easier to tell where things should get wired up. Shift registers, this is something that is available in loops. It is it's a wire that does actually get updated from run to run. Shift registers transfer the value from one loop iteration to the next. In this case, I'm going to initialize it to 1. Each loop I'm going to add 2. I'm going to store that, and I come back at 3, add 2, store that. And since I was told to run twice, that 5 would be the output to my output. Also, for documentations, labels are a good thing to do. I've commented here this is a free label. You can get that by just double-clicking somewhere and dropping a comment. You also have owned labels where you right-click on an item and say show label and fill in data. You can also do that on a wire. This is particularly handy when you start dealing with things where you want to keep track of, okay, this is the current value, this is the last value, and or this is the limit switch value or something like that. You can label these things and help them be more readable to someone who's not as right in it this moment, and that benefits you when you come back tomorrow or when you ask your mentor to have a look at it. Free labels have a pale yellow background and double click anywhere to create them. I should really be watching my preview to own labels help you explain the data. They move with the object, so if I click and drag this equal sign, this is an own label would move with it relative to it. And they have transparent backgrounds, and you get them by selecting and saying visible items label from the shortcut menu. Subdiagram labels are also available in the case of case structures, while loops, or case structures, loops, and a few other sequence things that I have not shown you yet. If you right click and say show subdiagram label, that's available. It gives you a chance to do a header on what should be going on in that step or in that mode. And this is an example on a while loop. Also, data documentation that's available to us. There are a lot of white papers out there online, and this is one based on IR-based line following. Interestingly enough, this is a great year to use this, so I would suggest you look back up this paper. It's actually using the Allen Bradley sensor, and this is a prototype as well as some analysis of how well this works using the this white paper in particular was published in 2018. Not 2018, sorry, 2012 with Rebound Rumble. Keyboard shortcuts, some of these I've used today, some of them I haven't. Control U will clean up the diagram. If I go here, I've got a lot of white space here, and if I hit Control U, it's a lot tidier. Notice there's a lot, not necessarily any wire bending. There's one there, which if I nudge this down with an arrow key, I can eliminate that. So this is nice and succinct. Okay, take a random number, multiply by 10, real short and simple. I should also note you can add white space by doing Control Drag. And one of the neat things in our newer version of LabVIEW, Control Shift. No, okay, let's see if I can remember this. Shift Drag. Nope. Is it Alt? I can never remember this. There's a keyboard shortcut for removing white space. I never remember what it is. Control's adding, Shift is just doing that. Oh, there it is, Control Alt. So Control Alt, I'm able to take the white space out. Control, I'm able to add it in. So I can quickly space things apart. I wanted to add something in here. Oh wait, never mind. Control Alt, drag it in. Quick way to clean up, nice and tidy. This is actually new to FRC this year. It was introduced in LabVIEW 2017, and now we're using, or excuse me, it was introduced in LabVIEW 2018, and now we're using that for FRC 2019. So this is a neat new feature that can help you keep your diagrams nice and clean. Right click to get the palette. I use that a couple times. Control space gives you the quick drop. So I can right click here and I can go digging for something that I know where it is. Or I can hit Control space. That gives me the quick drop menu. I can say, oh, I want the PID.vi. And that gives me the VI, and I can right click on it. Or wait, that's not available. I wasn't thinking. I can hit enter to grab it, or I can double click on it. And that gives me it really quickly. This is handy for things like, I want the motor. Read motor position. Oh, let's see. I think I want to set the motor. Okay, set output. Real quick, get to it. Not sure what it's called, not sure where it's at in all of this, but I can search and find it really quickly. Side note, you'll have a lot of occurrences where it says, hey, do you want to save this? This was updated. These updates are referring to when you opened it up, or rather when you used it, LabVIEW migrated it from the version of LabVIEW that was saved in to your current version. All of your deployment and stuff will run better if you just go ahead and save. It's fine. Some people are adverse to saving it ever. I encountered that this last year with the team I've been working with, but he found himself a lot happier when I got him to start saving these things. Control E switches you between the... you guys saying something?
No, we're good.
Okay. Control E is to switch between front panel and block diagram. Control Shift E takes you to the project window. Control R is what I was using to run. If you're in main that will run on the RoboRio if you're in a VI that is under my computer in the project or not in a project that will run on your computer. Control T is actually one that I avoided using. I find it handy when on a fairly large monitor. It splits my front panel and my block diagram so I can work with them. Interestingly, my resolution is set up in such a way that it didn't do it perfectly well. I should also note that with Windows 10, and this is something I'm really excited about, let's say I've got one of these and it's a big screen. If I do Windows left, nope, that did not do what I wanted to do. Maximize, please. Windows left. Okay, then. Maybe LabVIEW is not working with this feature. So I'll just leave it at that then. So that's actually what I've got in terms of slideshow for this one. How much time do we have left?
We've got the next section's at 2. We've got about 30 minutes. So.
Okay, so let's do this. Let's do, well, let me ask you this. Do we want to do some Q&A now, and then I can do like a demo setting up and running a program, or do we want to do a demo and then just Q&A?
Questions and answers, or say a demo? Demo, Matt.
All right, demo. So I'm going to basically close out of everything I created except for the main. My wife's actually back home now, and I can hear her going around. Anyway, so let's turn the screen share back on. Share screen 1, please. Okay, so I've got, again, this is very similar to what you'll pull up to. I'm going to go to the Tools RoboRio Imaging tool, because my Rio is not imaged yet. Actually, it is, but it's imaged to the wrong P number. And it is searching, and it's not going to find it because I forgot to plug in my USB port. Okay, so I've got a USB cord plugged into the RoboRio. Yes, you can have access. Rescan, now it should find it. Found it, cool. So I borrowed this from work. One of the defaults we use at work is 1111. My project's set up for 3288, so I'm going to reformat this to be 3288. And I'm going to apply that. Normally when you are, so I'm just changing the team number. The first thing you will need to do is select the format target and apply that so that you actually apply this year's firmware basically to the RoboRio. Firmware is not really fair to it because it's also got a firmware. It's got a firmware, then it's got a FRC image, and then your code on top. This particular RoboRio, I did actually have to update the firmware this morning. I don't expect most people will encounter that. This, like I said, I borrowed it from work. It's, looking at it, I think it's our 2017. No, this is a pre-shipping model. Okay, so it was set to this. It's now a 3288. I'm going to close out of the imaging tool. And I can double check that that worked by right-clicking on my target and saying connect. And if it's able to find it and connect up, then I know I'm able to deploy code. Okay, so I've got this little green dot telling me that I'm connected to it. And then under team code begin, I've got my extra motor. I actually don't really have a motor plugged in. I don't have any motors plugged in. I don't have motor controllers here at the house. More things, save all. Under teleop, I'm going to be a little silly. I'm going to blink an LED on the front panel because that's what I can do with the hardware I've got. So I'm going to leave that alone, and I'm going to create an indicator, and I'm going to call this one blink. And the quick implementation of how to do a blink is I'm going to go, I'm going to take the current time in milliseconds, This is milliseconds from system boot. And I'm going to do a division with remainder, which is under numeric. And I'm going to divide by, first I'm going to divide by 1,000, converting this to, now I'm going to divide this by 2,000, converting this to half seconds. I'm going to do another division by remainder. I want the quotient for that. I'm going to divide by 2. And the remainder on that, now this is going to break. I can't take that number into a Boolean, but if I right click, it's going to specifically give me an option to insert, if I go to the Boolean palette, there is a bool to 0 or 1. That's actually the opposite order I wanted to go, because I'm starting with a number, right? So I want to go all palettes, Boolean, number to a Boolean array. So now I'm Boolean on both sides, but I've got an array going to a single. I only care about the first one, so I'm going to, under the array palette, under the array palette, insert an index and just grab the first one by default. There are other ways to do this. I can do a comparison. This is a pretty simple way to just say, hey, I've got a number, I want to go back to 0, 1. I thought under the one of the palettes that we had a number to bool. Boolean to 0, 1, number to Boolean, Boolean. Apparently not. Okay, I do have a coerce. Coercion in LabVIEW works just like in any other language. I give it the value I want to coerce, and I give it the type I want it to go to, in this case a Boolean. And that doesn't like that. Not sure why not. What's your problem? Different types. Oh, never mind. That's not a value coerce, that's a boundary coerce. There we go. Alright, so that should run. And I'm going to run this on the Rio, so I'm going to hit and save. And I don't want to ever run teleop by itself. That will be all sorts of weird. In particular, what's going on is robot main is set up to loop the modes, versus teleop is run once and leave, and then main will tell me to run again. So I'm going to click run from main. Yeah, sure, save all. Save, save. Good news is I only have to do that once. It will keep asking me until it's got everything, but that should be the last time I have to do that. While that's going, notice on my desktop, when I installed the FRC tools, I got the driver station and the RoboRio imaging tool. I also installed that this morning, but I'll just delete that shortcut. You'll use this once. I accessed it by going through tools, but it is useful to have handy. Okay, so main is running. If I open up the driver station, first time you open your driver station, you will have to go to the settings. Oh, and here's another thing that uses vision. I'll just evaluate without extending evaluation. If I don't extend, it remains at 7 days. If I do extend, that basically means sign into my ni.com account. And that's free to register. That gives you 30 days. So I'm going to go to settings. I'm going to put in the team number for the RoboRio I care about, 3288. It's now got communication and robot code. If I go back to the operation tab, I can enable teleop mode. What I want to see is that blinking. So I'm going to go to the front panel. I'm going to enable, and my blink is working. So right up. Yep, there we go. It's going at half the speed I was thinking it was because I did it backwards. So I disable, stop the VI from running, finish on the robot main. It tells it to shut everything down cleanly. That should be the way that you terminate running from main. So this is going half the speed I meant for it to. So I'm going to just divide by 1 if I'm remembering right what I did wrong. yes, I need to save teleop to deploy that. Notice it's a lot faster the second time when running. This is why you would normally run to do debugs. And if I'm running, nope, I wanted to divide by 4, because that's going to be a really slow blink. And I'm just kind of poking at this with a stick because I don't really care. Oops, I don't have robot code. I have to run main. Yes, I did that intentionally, sort of. Okay, now I've got robot code, enable main, and that's still a lot slower blinking than I thought it was going to be. Oh, I know why. Okay. Notice when I hit finish, it automatically went to disable. It's because the code, when robot main stopped finishing, it undeployed, and the driver station said, I don't have any code, I can't run. I'm also getting output on the battery level. I'm cheating, I'm using a power supply, but that does, watch out for brownouts, things getting below about 10 volts, your motors will stop running. That only took me 5 minutes. Okay. I don't have a joystick here, otherwise I demo that part too. Are there any specific questions about running or deploying or anything like that before I shut my RoboRio back down? Sorry, that was a little distorted. I couldn't tell what you said. So that's not LabVIEW specific. That's a Windows 10 thing. I'll do it with some other Windows. So open up the game manual and an Excel sheet. If I do Windows right, it gives me the option of what I want to pair with it. And then I have this drag bar in the middle which adjusts both screens. I didn't know this didn't work with LabVIEW. It works with the LabVIEW version of LabVIEW I work on. So that was actually a little annoying to find out it's not working for FRC still. But it's a nice feature in Windows 10 that I take advantage of both at work and at home. I can close out of that now, actually. So that's what I was gonna do, was oh hey, I can probably do this. Oh, maybe it is gonna work. Oh yeah, it did work. Cool. Yeah, so my front panel's not very big, but my block diagram is, and I've got these paired and I can see them pretty easily. Actually, another feature that Windows 10 introduced, no idea if this is gonna work right or not. Do you guys see a blank desktop now? Okay, so what I did is I hit Control Windows right, and that moved me to my second virtual desktop. And you can manage those in the Windows tab menu. I can create more desktops. I can even, I don't think I can name them or anything. There are utilities that allow me to name them, available for auto hotkey, but that's not a huge priority in my book. One thing I would do though is I would put my driver station on a second desktop as well as the dashboard, so that I've got all my LabVIEW code, and then I can, oh, I need to get to the driver station, jump, it's there. Might do the same thing with the robot main, because I don't ever need to edit robot main, but I oftentimes need it to get to something, or to run.